Hey students, this is part 2 of my lecture on dependency diagrams. I just wanted to do another example of drawing a dependency diagram for writing a chain rule formula. And this one's going to be a lot more complicated because our functions are going to have more variables. So they want us to do all that for partial t partial x and partial t partial y. Okay? Where they give us the following information about the functions. So they say t equals k of uvw, u equals f of x comma y, v equals g of x, y, okay, and w equals h of x comma y. Okay, so really a lot more complicated than the last example I did. And they want us to find partial t partial x and partial t partial y. And we also need to do a dependency diagram. Your homework has dependency diagrams, and they're multiple choice, but they're still a little bit challenging until you get used to them. Okay, so let's start with partial t partial x. Let's start by making one for that. Okay, so dependency diagram for partial t partial x. So you always want to start at your first variable they give you. So here we're starting with t. Okay, so that's going to be the very top of our diagram. And here we know that t equals k of u comma v comma w. Okay, so that's going to be, t is going to be the very top of our diagram. And then we're going to work our way through these functions till we get to the bottom, which is supposed to be x. Okay? So what are we going to do here? Well, we know that t is a function of u, v, and w. So there's actually 3 different variables that t depends on. So we're actually going to need 3 branches, 1 branch for each variable. Okay, so let me give myself a little bit more room down here. But this is going to be 3 branches. Each branch is going to correspond to u, v, and w. Okay, so u is going to be the first branch, v is going to be the second branch, and w is the third branch. Okay? And then to finish the rest of our dependency diagram, we know that u is a function of x and y. And we also know that v is a function of x and y, and w is a function of x and y. But remember, we're doing partial t partial x here. So we don't care about the y, we only care about the x for this dependency diagram. So you start at t, which is in the numerator, and then you work to x, which is in the denominator. Okay, so the rest of our diagram is going to have all these branches, but they're all going to be going to this denominator, which is x. Okay, so each of these branches are going to go to the denominator, which is x. Our variable in the denominator of our derivative was x. Okay? And now we're set up to go ahead and actually write in all the partial derivatives. Okay? So remember, for each derivative, you start on the top and you go down the branch to get your denominator. So like here, this is going to be partial t partial u, because t's on the top. We start at t and then we end at u. So this branch right here is going to be partial t partial u. Okay? And then same thing for this middle branch. Starts at t, ends at v. So this middle branch is going to be partial t, partial v. And then on the right side, we have the same thing. So starts at t, ends at w. So this branch is going to be partial t, partial w. Okay? And then down here, we have the same thing. And these are going to be partial derivatives, not like the last one we did, because remember, u, v, and w are functions of two variables. So here we're going to have partial derivatives, since u, v, and w are functions of two variables. But all of these go down to x. So let's start with the left side. On the left side, we start at u and we end at x. So this branch here is going to be partial u, partial x. The middle branch starts at v and ends at x. So that's going to be partial v, partial x. And then the right branch starts at w and ends at x on the bottom. So that's going to be partial w, partial x. Okay? And then we've completed the dependency diagram, so we're ready to go ahead and write out the chain rule. So using this dependency diagram, and giving myself a lot of room, the chain rule is, well, we're doing the partial derivative of t with respect to x, so partial t, partial x. So partial t, partial x. And just like in the last example that I did, you want to go down each branch, writing all the derivatives. So let's start with the left branch. So working from the top down, we have partial t, partial u times partial u, partial x. So that's that very left branch. So partial t, partial u times partial u, partial x. And one way you know you're doing this right is if you look at this, it kind of looks like the partial u's would cancel and you get partial t, partial x. So that should kind of make sense to you, and it's in kind of an unusual way, but the partial u's look like they would cancel out, and that would give you partial t, partial x. So that means you're doing it right. It's just there's three variables here, so we also need all these other branches. Okay, so let's do the middle branch now. So working from the top to the bottom, we have partial t, partial v times partial v, partial x. Okay, so we have plus partial t, partial v times partial v, partial x. That was just the middle branch. Okay. And then working on the right branch, going from top to bottom, we have partial t, partial w times partial w, partial x. Okay, so we're going to have plus partial t, partial w times partial w, partial x. Unfortunately, the ones in your homework aren't quite as long as this, at least when you're actually calculating the derivatives. But when you're doing practicing the dependency diagram, they do get this long. But fortunately, you just have to set it up. You don't actually have to do any derivatives. So that's our answer right there. Okay? And then I also wanted to do the same thing for partial t, partial y. Okay? So, but I can kind of take a little shortcut here. So since I've already drawn this dependency diagram for partial t, partial x, we notice that u, v, and w are functions of x and y. So if I want to do partial t, partial y, I can literally just replace every single x there with a y instead. And that'll take a lot less work since we've already drawn this diagram. So if we want to find partial t, partial y, like I said, just replace all the x's with y's. So here we've got partial u, partial y, partial v, partial y, and partial w, partial y. And our final variable that we end on is going to be y. Now, how do I know all that? How do I know I can just do that? Well, the first part of our diagram was from t to u, v, and w, and that hasn't changed. The only thing that's changed is for partial t, partial y, we want to end at y instead of ending at x. So all that's really changed are these last three branches. Okay, so these three have changed and the variable we end up has changed, but the beginning of the tree is the same. And people call it a tree because it has branches, just like a real tree has branches. Okay, so there's our dependency diagram for partial t, partial y. Basically the same idea as the other one. It's just I replace every single x with a y instead. And then if we want to go ahead and do our chain rule, this time we're going to be doing the chain rule for partial t, partial y. Well, the setup's going to be very similar. In fact, we're really just going to end up replacing all these x's with y's. Because if we go down the left branch, we get partial t, partial u times partial u, partial y. Okay, so partial t, partial u times partial u, partial y. Right, that's the left side. And then the middle, we have partial t, partial v times partial v, partial y. Okay, so partial t, partial v times partial v, partial y. And then for the very right branch, we have partial t, partial w times partial w, partial y. Okay, so plus partial t, partial w, partial w, partial y. So notice it's the exact same formula as the other one. It's just we replaced every single x with a y instead. And it won't always be that way, but with this particular problem, that's how it worked. Because u, v, and w are all functions of both x and y. Okay? So there we've got our chain rule formulas all set up.